So I come from southeastern Europe, the faraway land of Bulgaria. I'm quite excited to be here, and it will probably show. Don't hold it against me. It's my first time presenting, so yeah. Okay, so let me present my talk in 60 seconds so you can make an informed decision whether or not that's where you want to be, although I obviously hope you'll stay. The idea is basically to introduce the serverless paradigm. This will be done using the AWS Lambda and Node.js. I'm going to go into detail why Lambda. I'm not going to cover in that much detail why Node.js, because this choice doesn't really matter that much. I'm going to show a very simple example, like the equivalent of a one-liner, and then I'm going to talk about two real-world use cases. The plan for the presentation is basically this: talk a little bit about me, talk a little bit about what is serverless, talk about AWS Lambda and the alternatives that there are for serverless computing, when it's appropriate to apply and when it's not such a great idea. My use case, the tips and tricks I've arrived to with regards to AWS, and a little bit of a closure at the end. Now this adds to 45 minutes. Hopefully we'll be done a little bit faster so that we have a little bit of time for questions. Okay, so a little bit about me. I got a bachelor's degree in pure math, and I'm still trying to find the application. If you do find, please tell me about it. I'm very interested in that subject. I've been a software developer for a while. These are the languages I've deployed code on, and at the far end you can see the shame corner, Visual Basic and PHP. Okay, jokes aside, I believe I've reached the point of language agnosticism, which to me is the point where you're no longer frustrated by having to learn new language, rather you're excited about having to change your point of view and see what is naturally expressible in another language, which to me is kind of a claim that I feel confident that I can program well. For the last 7 years I've been doing, however, information security, and in particular I do a lot of information security labs. So this would probably be my main role, besides management of course, in my organization, to oversee and often to get down and dirty and actually code labs which are designed to help the trainees get a deep understanding of an information security issue. The way I see this, the easiest way to do this is to actually force people to perform an attack, because this puts them in the shoes of the attacker and makes them understand exactly what they need to defend against. This is not just my vision, this is the vision of my organization as well. But the thing is that this is important context for the presentation as well, because this has informed the choice to go serverless. I'll talk about my use case later once again, but just bear in mind. Also, I believe that right now we're living in an age where practically every problem is a software problem. So that's why I'm really holding on to my software developer qualifications, if any. The point is that we're living in an age where software can cause tremendous damage and can also create huge value. And this is not something we can ignore. So we need to focus on software. That's why, even though I'm in an InfoSec professional's shoes, I still focus a lot on software. I believe this is a very important part. Yeah, and going back about the Visual Basic and PHP, here's what Dijkstra has to say about Visual Basic. Or not Visual, but just Basic. It's practically impossible to teach good programming to students that have had a prior exposure to Basic. As potential programmers, they're mentally mutilated beyond hope of regeneration. Kind of goes against my previous line. Yeah, what does this guy know? What does he think he is? Like the father of modern computational science? Come on. Now, jokes aside, I'm invoking the name of Saint Dijkstra with something else in mind. One of his other famous lines is that, what was it? Computer science has as much to do with computers as astronomy with telescopes. I think this is a relevant quote in terms of serverless, because hopefully the architectures that are spawned by the serverless model and the serverless paradigm get us closer to thinking about what we want to achieve and get us to think less about exactly how we're going to achieve it in terms of technology and in terms of getting down with telescopes of our profession, of course. Okay, my organization is the Cyber Resilience Laboratory, or CyRes Lab, cyreslab.org. It's a non-profit, just like its parent organization, the European Software Institute, Central Eastern Europe. George Sharkov is the director of both the entities. And we're a SEI partner. You can find us on the list of SEI, well, you can find ESICE on the list of SEI partners on the website. And we're quite proud of that partnership, of course. Our mission is to improve local and regional competitiveness through cybersecurity. We believe cybersecurity to be, right now, among other things, of course, a competitiveness issue, and that means that, you know, investing in cybersecurity will yield returns. And the IT sector kind of agrees with us in the sense that there's a lot of work to be done and a lot of people who are interested in collaborating with us. Information security education is one of our core goals in this regard, because let's be honest, if you want to have long-lasting impact, that's where you should be heading. That's how you make lasting change. Okay, so a bit of a disclaimer before I go into the meat of the topic. Subjectivity ahead. Now, I'll readily admit this is a bit of a cop-out here, because, yeah, I mean, first of all, everything is subjective. We are subjective beings and so on and so on. But the thing is, I may find my views quite different than the views of a lot of other people here with three regards. First of all, I work in a small to medium enterprise. Chances are that's distinctly different from many of you. Like, my impression is that most of the people who are present here are either in a large commercial organization or a government structure, and my experience may not correlate that well with yours. So there's that. That's the core reason for the disclaimer. The other reasons is that I have tried some parts of serverless. I'm going to talk about my experience with serverless, namely AWS Lambda and JavaScript as a language. Now, this is not the entire landscape, and I will not pretend to have the expertise to cover the entire range. Okay, after this, let's go to actually what we mean by serverless. Now, if you open up AWS Lambda, you Google it, this is the first sentence that comes out. AWS Lambda lets you run code without provisioning or managing servers. How does that work? Well, basically, you pay as you go. That's the business model. That's one of the core tenets of serverless. So if you use it just a little bit, you have to pay microcents at the end of the month. It also has what I like calling automagical scaling. In the sense that it's automatic, and in the sense that you don't really need to know about it. As a matter of fact, you don't really have a lot to do about it. As far as you are concerned, scaling will happen, and you don't need to worry about it. Okay. In order to achieve that, we have to elevate the function more than just the first-class object inside of our programming language. We need to elevate it to the core of the abstraction, which is why when most people talk about serverless, they mean function as a service. Now, there's kind of a religious debate going on whether or not serverless is function as a service, which one of the two is a larger concept. I'm not really interested in that debate. Basically, one of the core arguments I think is interesting enough to mention is that function as a service could technically describe any microservice architecture. So in that regard, you don't really need to have serverless in order to be talking about function as a service. However, until the end of the talk, I'm going to use serverless and function as a service interchangeably. And if you're a purist of definitions, my apologies. Yeah, of course, since this is the business model, we're going to be paying for executing functions rather than spawning VMs or launching containers or anything like that. Now, what is a function in this context? It's just a package code with a defined entry point, the function which is going to be started. Okay, I don't feel like I've given enough context here. So this is how probably the easiest way to get running in AWS Lambda. This assumes, now this is the actual Lambda function. I don't really think there's any point in explaining what this does. It sends something to the log. Yeah, of course, if you need something else, you're going to build it and so on. But the interesting part is the right side, which is about 7 lines longer than it should be. But this is because AWS has a lot of stuff you need to take care of before you run the first function. This is if you want to do it entirely from the terminal, by the way. You can do it far easier from the web interface like this. Like you can just say the name of the function, choose the runtime, say what permissions, say you use an existing role, or it can automatically create a role for you. And basically, from that point on, you're in a web IDE where you can edit the code you want to run. Okay, so here's the functional definition of function as a service that I'm going to be using, the ability to run user package code on demand, cheap and fast. Yeah, cheap and fast are rather subjective terms, and I own that subjectivity. I owned it already, but let me try to qualify this a little bit. Cheap, when you're running it low, of course, there's going to come a point where it'll be more efficient for you to actually spawn your own infrastructure and run something, an open source equivalent of basically a serverless platform on your own infrastructure. That's kind of inevitable. Maybe there's a point where it goes back to being more efficient on the public cloud. But the thing is, it's relatively cheap. I'm going to come back to this topic again later. And fast. Now, the other part about fast is that there's such a thing called cold boot, and I'll talk about it in a second. The idea of this is that if your function is executed rarely, you might have some boot up time. Why is that? Well, it's essentially a cache miss for Lambda functions. We're going to go back to this in a few minutes. Okay, so what does this code do? It downloads an example from AWS docs. It unzips it, it goes inside, and installs the npm package AWS SDK so that basically all of this is done so that we can do this, which sets up IAM, AWS IAM role, which allows the function to, run as a Lambda function. And this is all in preparation for this. Like this deletes the 18th line, which turns out is not necessary. This replaces the default name with another name of the role. Then we zip our function. Now, this is something that I found hilarious, honestly. The newest paradigm in software relies on deployment using zip archives. Okay, yeah, well, once you get over this, things get better. But the thing is, it's still quite funny for me because, we're going in circles in a way. And that's how you actually create the function. You say AWS Lambda create function, specify function name, what runtime you want, because you have various options for runtime, what role you're going to apply, and what the handler is, which the handler is basically the function that should be spawned when we call this function. Okay. Now, I already showed you how this works from the web interface. I assure you it's actually much easier from here. This is one of the great things about AWS, by the way. Anything you can do from the web interface, you generally can do from both code or, bash script. Of course, bash is technically source code, but usually we're not using it in this regard, at least the first time. However, it turns out that a lot of things that are very easy to do in the AWS website actually are very hard to do in code, or at least to do in a generic manner. Match functionality between the website and the command line or runtime in the SDK in another language. Okay, now a few words about the fundamental limitations of serverless. Now, the question mark here is because at this point I think it's not fair to say these are fundamental limitations of the approach. They're fundamental limitations of where we are with this approach. I believe that, even though some of these may seem irreplaceable, irremovable, and, in general, impossible to get around, it might very well turn out with time that there's something we're not seeing. Now, the first part probably won't go anywhere because it's probably the tenet of serverless, or at least function as a service in this context. It has to be stateless. And, the name Lambda kind of screams that because, of course, it's named after the Lambda calculus, where we're talking about pure functions. Now, our functions need not necessarily be pure, but they need to be stateless. What does exactly the stateless mean in this context? It means we cannot rely on traditional state-preserving mechanisms. I'll go back to this in a few minutes. We have a lot of practical limits on our functions. These cover runtime, memory usage, and a lot of other parameters. You may be thinking, oh, this is not a big deal, but this turns out to be quite a big deal. And once again, I'll go back to why this is a significant hurdle when you're trying to translate your classical code into serverless paradigm. Cold start. Like I said, this is the cache miss equivalent for functions. Basically, how this works is that AWS has containers, although from my point of view, the container part is entirely an implementation detail, and the only way we know this is containers is because of the cold start. AWS is maintaining containers wherein our function lives, and when the time comes, the container is spawned and the function is executed. Now, In case the container is not spawned anywhere, it has to be pulled off from a container repository. Maybe it has to be built even in some weird circumstances. I don't know. So this will result in a slower boot. However, once the first boot goes on, the next executions of the function within reasonable time frame will be much faster because there will be no boot time. This doesn't answer the question how we deal with things like scaling. Well, yeah, that's kind of disappointing a little bit because every time you have to spawn new instances, you also have this, but AWS kind of takes care about that because it will automatically spawn some instances which are just out there waiting in case it's obvious that our function is going to, explode in usage. And we also have less control. Now, this one is quite fundamental, and I also think it cannot really be improved or fixed away because that's the core of the issue, right? We're giving away control. Right? We focused on function as the core primitive, and that also means that we're going to have less control because we don't take care about the scaling, but the price we pay is that we have less transparency. There's this book, What is Serverless? O'Reilly book. Chapter 4 deals with exactly this topic. Okay, so what is the competition in this world? The main competitors are, of course, AWS Lambda, which I'll talk during the rest of the presentation. This is the IBM functions and the Apache OpenWhisk. They're together in one logo because, Blue Hat, the joke about IBM buying Red Hat, they actually collaborated on this project OpenWhisk even before the purchase was completed. I don't know if it was started already, but Apache OpenWhisk is essentially a project which aims to allow you to run your own serverless on your own private cloud. And IBM is running just that in their public cloud. In a way, serverless just means that you're going to be you're just going to be focusing somewhere else. Like there are solutions out there which take care of serverless in terms of Kubernetes, like you host it in Kubernetes. So in a way, it's not that new. It's just that the mindset of writing the code changes quite a lot. We also have Google Cloud Functions and Azure Functions. And I think it's safe to say that AWS Lambda is the most established function as a service platform right now. And that's because it's the oldest. Now, Google App Engine had a similar idea, but it was a much narrower implementation. I don't know if anyone has used this at the time. It had a lot of great ideas, I must admit, and it was older than Lambda, but it was much more limited. Because let's see what the platforms that are supported are for these use cases. Now, for AWS Lambda, you have Node.js, underlined because that's what we're going to be using. You can use Python. There's also various versions for each of these, by the way. There's also Python, Ruby, Java, Go, .NET Core. Microsoft support .NET, both the framework and .NET Core. They support Node.js, they support Java. All of those, which there I see no point in reading, the asterisk means that they have somewhat experimental support. Google Cloud Functions right now supports only Node.js, Python, and Go. OpenWhisk is the most open out of the all, but the thing is, OpenWhisk you run on your own infrastructure, so it makes sense that it will be the most open. Now, the place where AWS Lambda shines, and that's not just me, that's practically everybody who's using it saying, Lambda uses IAM roles by default. What does that mean? When you assign a role to your function, you say what privileges it has the right to use. And from that point on, you forget about credentials management. I cannot stress enough how great this is. This means that I don't need to deal with stuff like leaks of passwords because someone hard-coded in the Git repository or something like that. There's just no point in doing that at any time. AWS takes care of permissions on its own because I have already defined what permissions should be available to my function when it executes. Okay, this is in contrast to, for example, Google, where you need to define and use your own scheme to do credentials and permissions and so on. Admittedly, this is something I read about the Google Cloud. I haven't tried it myself. Maybe things have improved since the article that I read about it, but still, I think this is probably the killer feature of Lambda in comparison to the other platforms. as well as the generally deep support of runtimes. Although, as we can see, Azure matches that, and so does Whisk. Okay, what are the limitations and when it's a good idea and a bad idea to use serverless? Well, let's start with limits. Now, I know this is the wall of text. I really couldn't transfer this probably into a better visualization format, sorry about it. But you know, there's a lot of important information, even though it may seem just a wall of text-ish. We have memory limits, which start at 128 megabytes and goes up to what is a little bit below 3 gigabytes of RAM. Of course, it's incremented by 64 megabyte intervals. Why does that matter? If you need more resources, serverless won't do. Like that's just the upper limit. Also, if you need less than that, I mean, of course, you can do it 128, but the thing is you're going to be paying more. And if you need really small functions, this may not be the best use case. We have a time limit. This is, in my opinion, a much harsher limit because you're going to be hitting that a lot, in my experience. 900 seconds. This was 300 seconds, so it's much better now. It used to be 5 minutes, and let me tell you, 5 minutes is not enough to create an EC2 instance with 100% certainty. So if the only thing your code does is creates a single EC2 instance at peak peak usage times when it's the slowest and you don't pay for reserved capacity, your AWS Lambda may very well time out while you're waiting for the creation of a single EC2 instance. I have had that issue in production, and it's very annoying to deal with it, honestly. I'll go back to this a little bit later. Now, we have limits for the arguments we pass. Now, for synchronous calls, this is, I think, not really that big of an issue. 6 megabytes is plenty. But for asynchronous calls, 256 kilobytes, I can tell you from experience that you can reach that limit pretty fast because you want to be serializing a lot of stuff when you're passing it so that you can remove state, right? There's, of course, other mechanisms to deal with state. And this is just a few slides down the road. But the thing is, arguments are really easy when you want to do it. Like, you just put things you want the function to have access to in the arguments, and you don't deal with any other persistence mechanism. Yeah, well, not when you're talking about asynchronous functions. This is an important distinction, and I think one that's much bigger deal than maybe Amazon realizes. I'll come back to this in a little. You have 512 megabytes of temporary storage, so this is the /TMP. Your code size is limited to 50 megabytes when compressed and 250 megabytes when uncompressed. And once again, for a little bit of a laugh, we upload actual zip archives. You have no incoming network at all, and your outgoing network is only TCP and UDP. Also, you cannot send emails directly. The port 25 is blocked. Of course, you should be doing this through the simple email service anyway. So, out of all the issues, I think the email one is practically non-existent. But the thing is, if you're thinking of doing something, interesting network-wise, serverless is not really your choice. Well, at least not with AWS. You cannot use ptrace or anything like that in your code. And there's a lot of other limitations, which you'll find out basically by running over them. That's my experience. Okay, when is it good and when it's not? Well, first of all, this is my use case, which I'll cover in a little bit. Cloud integration and/or orchestration. This is great, and it's kind of obvious why. You have code which runs directly in the cloud, which has automatic access to APIs in the cloud. So you don't need to take care about permissions and stuff like that. It also has faster access to those APIs. It will take care of any orchestration issues of itself, because that's basically the promise and premise of function as a service. So yeah, this is of course pretty nice to do. Hyperscaling applications. This is probably the sexiest, if you will, application of serverless, and we're going to be talking about that in a bit. Responding to cloud events. This is nice because you can actually put Lambda functions which respond to any event that the cloud generates. Typical examples of this, SNS topics, S3 notifications, like for example a new file was uploaded to your bucket, and stuff like that. There's really no point in enumerating all of those uses, but basically, if there's a cloud event, you can attach a Lambda to it. And that's great. That means you can do actually automation of processes, of business processes using serverless. And you can not care about stuff like scaling, stuff like provisioning, and things like that. And I think that's great. As a matter of fact, this is the core reason for my usage of serverless, but this is also great, I think, and it's also informed my decision because it means I do not have to take care about things like how many instances I need to run this code. Okay, so what are the use cases that I think are not that great for serverless? Well, highly dynamic or heavy input-output or heavy CPU usage tasks. Why is that a bad idea? Well, recall these limits. Like, if you really need to bend the limits, you probably should not be using serverless anyway. Now, there is a way around this, and I'll go back to it in a second, but the thing is, you should probably, the serverless part should probably deal with splitting the tasks and maybe assigning them to containers or EC2 instances that will do the actual work, and have the actual work handled in another form of infrastructure. Static websites. Yeah, sure, like, of course you don't want to be serving static code through such an elaborate mechanism such as serverless. AWS has a much simpler stack for this, and I've seen this once or twice, and I raised my eyebrows as a response because it's very weird as an idea. Why would you even start doing this? And static through output workloads. If the through output is static, you can usually design an infrastructure on the infrastructure as a service level, which can handle this perfectly well. So the main bonuses of serverless are lost if you do not need dynamic scalability, if you do not need any sort of dynamism. Okay, so going back to hyperscaling applications. This is where the core promise of serverless comes to fruition. If you implement it properly, function as a service can achieve infinite scaling. Now, as anybody else, when I hear infinite scaling, something's off. Like, infinite scaling sounds wrong on its own. Nothing is infinite, and every engineer knows that infinity is the fastest way to lose track of reality. But the thing is, infinite scaling in this regard is kind of close to reality, because what it means is that until there are free resources in the AWS region where your code is running, your code can scale. And that's a lot. Like, we all know that an AWS region is huge. I haven't tried taking over the entire region because, well, let's be honest, I don't really have the money to test it either. But it's a huge, the largest cloud infrastructure provider, so it should be a really big, scaling issue that you have so that you can take down the entire AWS. Okay, however, in order to do this, you need to be implementing this properly. And properly in this context means you got to remove all the scaling bottlenecks. What will be those scaling bottlenecks? Database, first scaling bottleneck that you usually encounter anyway. Well, AWS has a stack just for that. It's AWS Lambda combined with Dynamodb, their, how do I say it? Their planetary level DB, if you will. S3, because S3 is mostly parallelizable, that there's almost no limitations on S3 as long as you abide by some rules like split by prefixes. API Gateway, which also has AWS level scaling, and CloudFront to deal with the static parts of the website. If you're using this, chances are you're going to hit an issue with an external API, because let's be honest, usually everything you want to do cannot remain entirely in the cloud. You're going to be calling an external API, and if you really need infinite scaling, chances are the external API will be the first point to break down. Okay, so a few things about, do you know what this is? This is the logo for AWS API Gateway. Now, the world speak HTTP, or rather HTTPS hopefully, and so must we. Unlike some of the other cloud offerings in terms of serverless, the AWS Lambda is not intrinsically bound to HTTP request in any form. Calling an AWS Lambda function is a first-class operation. Like AWS Lambda is its own service, calling a function is its own command, and so on and so on. However, you can of course integrate this with a web API, because otherwise what would be the point? The product that does it in the AWS ecosystem is the API Gateway, and this is something that I found out the hard way. The API gateway time limit is much less than the Lambda time limit. Now, this makes perfect sense when you think about it from the HTTP point of view. Like everybody knows long requests should be handled with polling, right? However, from the Lambda point of view, this doesn't really make that much sense to me. Because when I was designing and writing my code, I read the AWS Lambda limits. I wasn't thinking about the integration limits. And all of a sudden, I got hit with this somewhat arbitrary, from my point of view, limit in the API gateway. So I'm thinking, shouldn't AWS be doing that for me? Like, shouldn't it be handling the abstractions of long polling and so on behind the scenes? The way I fix this is create async versions of the functions, which are essentially thin wrappers. So I call the asynchronous function. It is guaranteed to return in, I think, 3 seconds is the limit here. I've forgotten the actual number. The async function is guaranteed to return in 3 seconds. However, you don't really know what's the result of the Lambda function. You need to poll it in some other way. That's usually okay, since if the Lambda function is going to take long, you're going to be having another mechanism to control its execution anyway. But the thing is, remember the limits a few slides ago? Now, you can call functions with 6 megabytes of arguments for synchronous, but only 256 kilobytes for asynchronous. So this is another issue you might hit, because when you go down this road, all of a sudden the size of the arguments falls rather, with a few orders of magnitude. And in general, this has multiple drawbacks that, I can wish that you don't experience. But there's a mismatch, is what I'm saying. This is a abstraction mismatch in my view. Okay, let's invest a few minutes in talking about the AWS storage mechanism that's supposed to be coupled with Lambda, the Dynamodb. So how do we deal with persistence using Dynamodb? It's a NoSQL database with extreme level of scalability. How extreme? Well, there's essentially one DynamoDB instance running per AWS region, and even that may not be true because you have global data in DynamoDB. So from a certain point of view, you might say the entire AWS is running a single instance of DynamoDB. This is not stuff like the RDS service where AWS will just spawn instances of virtual machines which will support your own database. No. You have an API with which you connect to DynamoDB, and there's a single DynamoDB. You don't really care about how it works under the hood. You don't really care about anything. Now, this is the thing that enables the infinite scaling, because without that, we would still be stuck with the cap theorem. Well, obviously, no one has solved the cap theorem, but the thing is, we all know in practice, you don't need to solve it. You need to somehow suffer through it. DynamoDB is kind of a way out. Of course, we're still going to suffer through the consequences of the cap theorem, because you have strongly consistent or eventually consistent reads. The thing is, strongly consistent reads fail availability. Of course, that's the cap theorem. You got to fail one of those. And eventually consistent reads, you have a very weirdly defined guarantee by Amazon, which basically reads something like, and in about 1 second, the data will be globally consistent. Great, but that's not really a service level agreement. That's not anything. That's just like saying, we found out 1 second is enough. Will it be enough in practice? Nobody knows. I have read some comments with regards to this that people have encountered issues such as data corruption due to this, and thankfully my use case is small enough that I don't really hit that stuff that often, and it hasn't happened yet to me, but I can definitely see that being an issue. Also, index support is rather limited. In general, you have one index, you can add secondary indexes, but things go down there. Like it's just a rabbit hole, and my view is if you can fix it with a single index, you'll be happy. If not, you're going to suffer the pragmatic consequences of your choice. Okay. Now, technically, I could probably talk more about this, but I shouldn't because this is a topic on its own, and it's not really my job. So, what to do with AWS Lambda limits that happen to be weighing you down? Well, you can provision EC2 or ECS instances, or you can deploy CloudFormations, and in general, you can spawn any sort of cloud infrastructure that help you deal with larger workloads. And serverless is rather a good way to do this. You find out how much infrastructure you're actually going to need for the task at hand. You spawn the infrastructure, you work through the task, and then you close down this infrastructure. Some other stuff that you can do: create, delete S3 buckets, handle IoT events, handle S3 events. Anything in the cloud that happens, you can do it with Lambda. Don't forget to pay your IAM tax. What I mean by this is don't forget to define actually reasonable policies. This is probably the #1 security issue. More on that later. A few tips. Automate deployment. Creating zip files is ridiculous as an approach, so the only way to deal with it is to automate it. You can either use CI/CD pipeline of some sort, or you can use GOP, which is a build system for JavaScript. This is what I chose for my use case. Of course, these are not mutually exclusive, but right now I'm doing fine with GOP. You can actually run locally Lambda. I don't know how legal is this, but Amazon doesn't seem to have taken any steps towards taking this down. It's a GitHub repository, which has also a Docker container, which is the exact content of an AWS Lambda execution environment. And it supports all the runtimes. So if you have a way to also locally debug in the language or runtime you're using, you can also do that as well. This has been immensely helpful for me because it's much faster doing this locally than generate the zip file, upload the zip to the cloud, wait to get a new version number, execute the new version number, wait for the logs to appear, analyze the logs, go back to debugging. This is much faster. The other key advice: test on a separate AWS account. AWS organizations allow you to consolidate billing, so you can create test-only accounts. That's what I did. So even if all things go south, nothing of critical importance will be touched at all. There's just no way one account accesses the resources of the other unless you've specifically delegated privileges. Okay, a few words about my use case. So the project that I did is called Course Manager, and it orchestrates cybersecurity course infrastructure. What does that mean? A simplified view is this: I create an EC2 instance that hosts the exercises, and bear in mind, infrastructure is important from the cybersecurity point of view because oftentimes you have vulnerabilities which are at the infrastructure level. So even if, say, I'm doing a web security course, I cannot just say, well, that means I'll deal only with an web API, and I can just expose the exercises as APIs from, say, API Gateway or something like that. No, sometimes we're talking about infrastructure vulnerabilities, and as such, I need to have dedicated infrastructure for that. So that's the reason why I create EC2 instances. Then I send the participants emails which contain the slides and the links to the system. I schedule the time when data will be collected from those instances and they will be terminated. And it also manages surveys so that people can give feedback. Now, I'm not using the microservices approach because I'm using the same code base for all Lambda functions. And I suffered somewhat because of that. Now, this is a CloudCraft diagram. If you haven't heard of CloudCraft, it's, in my opinion, a great tool to model AWS architectures. I'm not really going to go through all of it because I don't really have the time, but this is basically 5 Lambdas, and everything else is an AWS service of some sort. This is coupled with an API gateway and a purely static front end, which I'm proud of, so let's get to it. I have no centralized storage mechanism beyond Dynamodb, which means I don't care about scaling at all. Well, right now I don't. Maybe one of these days I'll find out that I actually do. I have very loose coupling between backend and frontend because the frontend basically can call one of 5 functions through an API gateway, and that's it. This allows me to have a fully static frontend, which is delivered entirely through S3, through the CloudFront, which is essentially a CDN of sorts. And as front-end technologies, we use Vue.js plus Nuxt.js. This is modern stuff, supposedly. My team tells me I don't do front-end, and I'm very happy about it, honestly. The back-end code is 3.8 thousand lines of code, which I think says it's a rather small project. So yeah. Okay, this is how the front-end looks like. My colleagues really wanted me to show off this. It's not too, I don't know, eye-catching, I think, but it's really functional, responsive, all of the cool stuff. So yeah. I have another smaller serverless project which I'm working towards. It's called the auto start, and the idea is this. You have a demo machine and you want people to be able to start it when they want to. However, I don't want it to be running 99% of the time with no users, so it automatically shuts down when there's no usage. How does that work? When the VM is stopped, the DNS points to a static website where the user can actually request with a button the launch of the virtual machine that's the demo. Of course, you got to use either capture or authentication for this. Then the Lambda function creates that VM and updates the DNS. If you're thinking DNS is too slow, AWS has a hack to make DNS updates almost instantaneous in certain use cases, such as this one. Too off topic to cover, but you can find it if you Google it. The VM itself postpones its own deletion as long as there are active users. And yeah, I fully intend to open source it when it's done. It's not done yet, but I think it's a really cool side project which can be useful outside of my own personal uses. Now, cloud impressionism. So impressions, my impressions. Serverless is fun. It's very inspiring to be able to build infinitely scalable apps with just a few hundred lines of code. And the thing is, you have access to all the other cloud APIs. So also forgoing the old school persistent school of thought, so no file system access, no small database, it's also very liberating. So it's definitely fun when you start. However, scheduling is way harder than I expected. This is how I schedule in Celery, which is a task queue, distributed task queue in Python. That's it. I say in 60 seconds, provide these arguments to this function. That's all. This is how I do it in AWS, and this is just the description. The actual code to do this is 90 lines, and the file, and you also need to clean up permissions and rules after the execution. The AWS forces you to deal with stuff like retries, stuff like early wakes, because it's not 100% reliable, like you do not have second level accuracy. And from my point of view, this is solved by syntactic sugar on the part of AWS. Versioning is not fun as well. If you're using microservice architecture, you're probably not going to be caring about that a lot. But since I'm reusing code, I had a lot of, well, lack of fun. My anti-pattern, I had to release. I had a distinct operation release that deploys the code, pushes new versions, updates the configuration for this code, and then pushes again new versions. This is all necessary, turns out, and it's ugly. It should not be this way, in my opinion. I don't know how to fix it. It's not that big of a deal, though. The thing that I think is a big deal is there's no async await for lambdas. And I don't mean JavaScript async await. I mean the idea behind async await. A sync function is not really a function at all. It's just multiple functions which are chained by syntactic sugar. Why is Lambda not doing this for me? 90% of my runtime in Lambda is spent waiting for AWS resources to be spun up. So from that point of view, I feel like AWS should be doing this for me through syntactic sugar, allowing me to just chain a few AWS API calls and have my code awoken, have the next Lambda awoken so that it can take care of this. Otherwise, we're going back to callback hell, which is a very well-studied topic in JavaScript. A few words about security. So the AWS security model is you're responsible for security in the cloud, while AWS takes care of security of the cloud. That means AWS should protect you should another account get breached, but it's your own job to not get breached. Serverless reduces the attack surface because you generally cannot gain persistent code access. Like if I hack into a container, this container has very limited time in which it will be alive, so there's that. However, you also have security updates applied for you in the OS level, for example. So the only vulnerabilities at that level which should come from your own source code, and that's your responsibility, of course. So that's great. However, if I get remote code execution in your Lambda and you have not paid the IAM tax I talked about earlier, I can take down your entire cloud infrastructure. Because remember, the kind of AWS API calls I can do depend on the role you've assigned me. And the role has an attached policy, and if you've given me the right to do everything, I can do everything, and the attacker can as well. Almost all web vulnerabilities are still relevant if you're going to be using AWS Lambda as a backend to an HTTP service. And also we have denial of wallet, which is the cloud version of denial of service. Because instead of having your service denied, you have your wallet denied because the cloud will scale, and you're going to be asking the bank, where's my money? So, denial of service is solved, but not really. I have a few words about vendor lock-in, but time has really run out. Basically, in AWS, it costs $1 to get in and $1 million to get off, because hopefully you've scaled up to that point. There are some solutions potential, but they're not ready in my opinion, and there's leaky abstraction between different cloud providers. And finally, if this seems like an old idea, it kind of is. It seems like we've rediscovered event-driven, because if you remember about the time that concurrent 10K connections was a big deal, we were having similar discussions like Python twisted, and also the move towards loose coupling has been going on for a while now, like microservices. So it's just these two concepts combined from one point of view. From another point of view, however, you have the exabyte level hardware that can back up infinite scaling in the cloud. You also have native integrated cloud API calls so that you can do anything in the cloud you want. And you have enforced small functions, which hopefully should lead to better quality of code.